You can see the title here. I'm Andrew Brandt. I'm the Director of Threat Research for Blue Coat Systems. I came into Blue Coat from their acquisition of Ssl Networks, which is a network forensics and network analytics company. And I'm going to talk to you basically today. I'm going to talk about some of the context of the threats that we're seeing in the lab. Just so you guys understand what I do, I infect computers with malware to observe their behavior both on the machine, but more importantly over the network. And that the information that I am able to get from that is fed into the reputation service that underlies a bunch of Blue Coat's products, including their proxy products, as well as security analytics and other things. And we're able to basically see what the current state of the malware landscape looks like on a weekly or daily basis. And there's a lot of stuff that's bad, and I'm sure you know, that's going on that affects the private sector, who are mainly our customers, but obviously you guys and the public and in the public sector and the private sector, there's no distinction in terms of the criminals from your networks or the networks of a big bank or a healthcare company or an oil producer. So really, as far as sectors go, there's really no distinction, and it's very important to be aware of these things. So I'll just jump into it because I've got about 35 slides. And it's not working. Let's try that again. Okay, so here's what we're going to talk about today. Basically, it's going to be an overview of current malware threats and how I do my analysis of them using a bunch of tools that Blue Coat has acquired as part of their acquisitions just in the past year. So Blue Coat, if you know of them, they're pretty much well known as being a web proxying and cache company. Their original business was basically around managing bandwidth for large organizations when it was expensive. That's really no longer the case in most parts of the world. So they've spun what was basically a small piece of their business into this bigger security architecture that they've created that's called, it's basically the entire security landscape kind of wrapped up into a few products. So we'll talk about that. Here's the reality of sort of today's situation in the enterprise world, and probably in your world as well, is that we have these huge numbers of security products that we're using to protect our networks, we're using to scan our email, we're using to preserve the integrity of our desktop PCs, and I guess in some cases our mobile devices. And yet, even with all of these things that we are using to basically protect ourselves, the problem with incidents of data loss keeps going up. Right? The bad guys don't seem to care that we're installing a fancy new IDS or some other new kind of product in our network because they're getting through anyway. So these are basically the problems that everybody is facing. And so when we talk about the nature of these issues, we're talking about stuff like this. So your typical attack is going to have three phases. The first phase is this sort of attack and social engineering phase, where they're trying to convince the user to do something, whether it's click a link, open a file, follow some person on Twitter, whatever it is. It starts like this, and they're very realistic. It used to be that we could identify spam by the fact that it was poorly spelled, it's got bad grammar, it just looks clunky. Those days are over. We're into the days now where they're using CSS and nice graphics, and they're emulating the real stuff. Once these things happen, that's when all the fire starts to happen. So, excuse me. What we're looking at here is an exploit kit in progress. And I apologize for the small screen, but let me see if I can illustrate some of what I want to show you here. The visitor to the page who clicked that bad link in that email message just sees this. Please wait, page is loading. There might be a little Java spinner in there telling it that something is loading. This is just a little cutaway from a program called Process Explorer, which is kind of a task manager on steroids for Windows. It's free, and if you're not running it on your desktops, I highly recommend it. This is showing you that Firefox was running, that the Java plugin got loaded. The plugin container is basically the Java app that's running within the browser, and that as a result of that plugin container running the Java app from this page, a program called wbmp0.dll got loaded out of the temp directory, and that basically that's it, you're done. The infection has occurred, the machine has been compromised, and then this last step, which is fun, is that most of these tools have a little self-delete script that they run at the end. So once they've infected the machine, they delete the initial installer. There's no trace that it was ever there, but all the stuff is basically running in memory. It's hooked to a legitimate process, and or there may be a copy of it running on the system, so that when you reboot, the registry will load this little program here, and you can see that they've gone to the trouble to even name it servicehost.exe and put it in a directory under application data on the machine and call it Windows Update, but they forgot to change the description of the program, which says buying with Poly, no registration required. It was basically an off-the-shelf keylogger kit that these guys basically used to infect this machine. Finally, once the machine is infected, then the malware basically has total control of that machine, and it's able to do whatever it wants. Usually we're seeing stealing of passwords from all installed internet-capable applications, so that means not just the browser or the email client, but any FTP client apps or anything else that you might use to manage something on the internet, instant messaging clients. And in addition to that, they will use different techniques to laterally spread themselves. And the screenshot that I wanted to show you here was one of those methods that I thought was more interesting than most. This was a worm that copies itself to a thumb drive after it has infected the machine. Now, I run tons of these in the lab, and I periodically just use thumb drives to copy screenshots or other things off these infected machines before I wipe them clean. And what I had done was I had this thumb drive that was full of my notes from different investigations on it, stuff that was throwawayable anyway, so it didn't really matter. When I stuck it in this machine, the malware, as its method of spreading, copies itself to the root of the thumb drive, calls itself porn.exe. It then takes all of the folders and files that are in that root of the thumb drive, marks them as hidden, so that normally in Windows you wouldn't see them. On mine, I see hidden files and folders, so that's an easy setting to flag. But then it makes a shortcut of all of them, and so that when you click any of these things that look like folders, it would basically launch command.exe, start, porn.exe. So very interesting, but again, easily noticeable. And if you have auto run turned off on your Windows machine, sticking the thumb drive in doesn't cause any actual damage, but you'll see all of this changes to the drive. So to do the analysis that I do, I'm using basically 3 tools. I use a program called Security Analytics. Security Analytics is in essence a full fidelity, high-speed packet capture solution for big networks. We're talking up to 10 gigabits burst, 5 gigabits sustained in some of the higher-end appliances that they sell. What it does is it records all of that data, and as the packets are being sprayed onto the disk, it's passing those packets through DPI engine. The DPI engine is extracting roughly 200 pieces of metadata, attributes about the packets that are of interest, which we can later use to go back and figure out what happened and search for that stuff. And then once we have found those things, you don't have to look at this stuff in Wireshark. We then will reconstruct files and what we call artifacts from HTTP, FTP, email, IM, etc. And you can basically go back and reconstruct the entire session and see it from the perspective of the person who was infected, or the machine that was targeted. We also do Ssl Decryption. The box that we call the Ssl Visibility Appliance is an inline device. It's a fairly high-end machine. It takes a lot of CPU cycles to do what we do, but it's a real-time man-in-the-middle attacker. And what it does is it sits there between the outside world and your inside of your network. As HTTPS connections are being made, it's intercepting the certificates, sort of unsigning them, re-signing them with its own certificate, and sending it along. So the end user doesn't see any effect in terms of their browsing experience, but you get all of the decrypted traffic from those sessions. Very interesting stuff happening in SSL. We're about to publish an SSL report at the end of this month, which I'm writing about the kinds of malicious behavior we're seeing through the SSL tunnel. And then finally, we're using these tools called the Malware Analysis Appliance, which is essentially a VM inside of another machine that we put a piece of malware on, tell it to execute, observe all of its file system and registry behavior, and then spit you out a nice report. This is what the SSL Visibility Appliance looks like, and this is the UI of the DMAA. This report in particular, I don't know if you can see it, is FinFisher. FinFisher is the law enforcement Trojan that has gotten some agencies in trouble in Europe. We classify it as risk level 10, not because it's FinFisher, but because it's doing these certain things which we have written patterns for. Patterns are basically open source rules defining heuristic behaviors that a piece of malware might engage in. And based on a scoring mechanism that's basically transparent in the UI, we can just come to a conclusion that this is really bad, never having seen it before, based on the fact that it's running something from the application data folder, and it's creating programs on the system, and it's rewriting the boot sector, the hard drive. So let's talk about some of these usual suspects. I'm a big fan of this movie, so I always like to get that slide in there. The spam attack vector is one that I've been particularly focused on for the past 2 years. I've been working on a research project to analyze spam to determine the characteristics of spam messages that are more likely to indicate that they are engaged in bad stuff. And what I've discovered is, so over this year of doing the research between March of 2013 and this past March, we saw this rise in these are basically incidence counts of malicious spam activity. And you can see that it's just been steady for the whole past year. There was a little spike right here, right around last October. Does anyone remember something called the black hole exploit kit? So right around mid-October last year was when a guy named Ponch in Russia got arrested. He was the guy who had created and has been selling the black hole exploit kit, which had at that time been the dominant method that these guys were using to infect machines. As soon as he got arrested and his thing went offline, it basically threw the entire malware community into a tizzy for about, I don't know, 2 weeks while they were trying to flail around and find something to replace it. But it didn't really stop them because they just kept on going right after that. So let's talk about some specific spam-delivered malware. So Upatri is probably something I would be surprised if everyone in this room hasn't seen this at least once. It comes as a very small zip attachment attached to a very realistic-looking spam message. I've shown this one that says it's from Ring Central, and that the message is supposedly a fax. It says fax.zip. But the social engineering aspect of these messages is very broad. It could be a voicemail message, a shipping confirmation, an order form from some online store. They're all very realistic, and they all basically have a small zip attachment in the email message. The attachment is the Upatri Trojan. It's called Upatri because for the longest time, these guys, when you would run the Trojan, it would use the user agent updates downloader. So it was actually very easily identifiable using our security analytics product, because all you got to do is look at the user agent report and see everything that said updates downloader, and then look at all the machines, the IP addresses where that came from, and those are all your infected machines. So this is what updates downloader does. It is a single-purpose, very small but very specific Trojan. Its job is to get one payload and then delete itself. It just basically gets its thing and vanishes. These are examples of some of the URLs that were used to host Upatri payloads, the things that it downloaded. And it's changed its methodology a little bit over the years. We first saw it at the beginning of last year in very small amounts, and now it's become one of the dominant Trojans. It started out just delivering the payloads as just straight executables over HTTP, very easy to extract and see the payload, no problem. Then they switched to using SSL, still just the regular executable, but in SSL, so the visibility appliance was able to decrypt it. We still just got the files. So its latest trick now is it uses the file suffixes of different legitimate files, as well as other just kind of random three-character, three-character, letter salads, basically. And it delivers an encrypted file over the network, which doesn't get decrypted until it's written to the file system of the infected machine, at which time they run their decryption algorithm, detonate the payload, delete themselves. The payload does its own thing, which usually involves deleting itself. And again, it's kind of gone in a few seconds. This is just a slice from the security analytics tool showing how we reconstructed one of these artifacts of Upatri downloading something. And it presents itself as a zip, but we are able to do a little magic on it and show that it's actually just a binary data file. All right. Here's Kuluos. Kuluos is another one of my fan favorites because it's been around for a while, although they took about a 9-month hiatus and only just started up again about 2 weeks ago. So it's kind of cool to see Kuluos back. Cool in a certain perspective. But basically what it is instead of it being an attachment, they're giving you a link in one of these fake messages. And you can see that this one was from 9/17, so it's just from last week. Here's the link, and the link is to this page that's on this website with a .ru suffix, right? So it's coming from Russia. And in fact, this site was actually hosted on a web server in France, but registered in China to a Russian guy with a Russian name, and it was a .ru domain. So there's lots of bad stuff kind of going on with this domain. But the interesting thing about it is that some of the characteristics of these URIs are very predictable. And we've actually just written regexes that just look for all new URLs that sort of cross our wires that have these patterns. It's very easy to find them. When you click the link, it just delivers you a zip. But it doesn't just deliver you a zip that says fax.exe or delivery notification.exe. It looks at the IP address that your request is coming from. It does a little bit of geolocation on the server side. It takes it about a quarter of a second. And then it delivers you something with a name of the city that you're downloading it from, or in some cases, the city and the area code if it's a phone message scam. So this geolocation is just kind of interesting. It will give you the zip file will be called the same thing as the contents inside. You can also see that, for the things that say they're an address label, it kind of looks like a Word doc, and the one that says it's a voicemail message looks like a little, WAV file. Again, this thing is basically a botnet Trojan. Its purpose is to bring down other payloads. It's a delivery mechanism for other malware. But it remains on the machine, and it continues beaconing over an extended period of time. Here's how we find it. It's HTTP posting on port 8080 every single time. Well, not every single time. Occasionally it's on port 8090 or 8088. But all you got to do is just look at a lot of traffic that's doing posts on basically a regular frequency. It could be every 5 minutes, every 15 minutes, to a weird URL that kind of looks like this. Big long strings of random letters and numbers. Occasionally they have a little, request or options flag, because the contents of these are the command and control traffic that the bot is using to send stolen data up, get instructions back, and it does this thing basically all day long, and it's very easy to find it. So here's another interesting vector that we've been seeing grow over the past 18 months. My colleague, who's a guy named Chris Larson, has blogged about this for years, and the advertising industry and the rest of the security industry is kind of finally starting to catch on to this problem that we call malvertising. And the idea is that you're visiting web pages in your browser that you would not normally expect would be engaged in dodgy stuff, but those web pages host banner ads and flash ads and things along the margin that maybe you pay no attention to. But those ads themselves can be manipulated and contain malicious code or be weaponized to deliver the browser, without the user's knowledge, to sites that are doing bad stuff. And they deliver it with these very obfuscated chunks of JavaScript, which, when you decode it, are usually just basically a redirect to another site. So this is a screenshot. This thing and the thing down here at the bottom is a screenshot of an attack that happened last week on a major ad network called Zito. Zito is hosting ads for thousands and thousands of websites, including very popular large websites. And they got owned in a pretty severe way. And the malvertising thing is generally happening not just on desktops, but on mobile devices. One of the other focuses of my research has been attacks against Android from various vectors, and malvertising is a big one. Although these kinds of attacks don't tend to happen on the big major sites, they're still happening with a lot of frequency. This one in particular, I love the fact that it says it's a generic Android tablet security alert as opposed to the very specific kind. And the attack basically delivered to the Android device what we call a potentially unwanted app, or a PUA. It was an app that basically was junk, where they tried to convince you that it was some kind of antivirus scanner, and you had thousands of viruses on your machine, but it wouldn't remove them unless you paid their license fee. Right. So here's just some slices of the Zito attack that I was telling you about a minute ago. It started with this URL, okay, which is actually in Zito's namespace. It was one of their JavaScripts that they used to load Flash advertisements. It had been hacked, and it had one of those little redirects into it. This was also a redirect. The first one redirected to this one. This one redirected to this one. And then this was where the actual attack took place. This uni.me is a dynamic DNS service. It's like vindns.org. And so anybody can just register as many free subdomains of uni.me as they want and use them for as long as they want. And this service has been abused pretty badly by a bunch of criminals for the past, 6, 7 weeks. It's been really just under fire. And there's not a lot that they can do about it. Once this thing loaded, this is the exploit itself. The exploit kit is called Nuclear. And Nuclear Exploit Kit looks for Java version, and Adobe Reader version, and Flash version, and Silverlight version. And based on what you have installed on the machine, it will then deliver exploits that are targeted at those particular versions very precisely. So it was a very quick infection. In fact, you can see that the next thing it delivered about maybe 35 seconds later was this Silverlight file. And as a result of that, the infection basically took place. And in fact, it didn't just do the Silverlight attack. It also noticed that I had a vulnerable version of Java, so it did a Java attack as well. And it delivered 2 DOS executables that were the same size within about 3 seconds of each other. So within 36 seconds of visiting a page that I didn't know my browser was on, this thing was already running a piece of malware, which then, about a minute later, downloaded 2 more pieces of malware. So bad stuff. And then the worst part of it was, none of these pieces of malware, all these things that say dissects, none of them were known to an antivirus company until I personally sent them in to VirusTotal and scanned them. And when I came back with the results, I was a little disappointed, because there was only 4 AV engines that could detect anything at all, and 3 of them, it was just a generic heuristic, something about this might be bad. It was only this company from Korea called OnLab that knew that this was a dropper called Neckers. And Neckers is pretty bad because in addition to delivering other payloads, it also rootkits itself on your machine. And to do the rootkit, it has to force a reboot. So about 15 or 20 seconds after the infection has finished, it reboots your machine. Doesn't give you any warning, just boop, gone. So any work that was open, it's done. So, and that's a good segue into the SSL piece of this talk, because one of the Trojans that Neckers was delivering was this one called Dire. Some people are calling it Diarrhea. I don't know why the name is so weird, but basically it's a Ukrainian Trojan that is using SSL to mask all of its command and control traffic. And it's been an interesting focus of my research for the past 6 weeks because it only appeared, I don't know, about 2 months ago, right after the Zeus botnet got shut down by the feds, when they took control of all the Zeus infrastructure. Basically, Zeus was out of business, and once again, kind of like what happened last year when they arrested Paunch, the criminals were flailing around looking for something to replace it quickly, and they've basically focused on this one from Ukraine called Dire. This is basically an indication of what the infection looks like. Again, only if you have Process Explorer and only if you're watching at the second that it happens. So what we've got here is this thing with a kind of a little PDF icon. That was actually Upatri. So it ran. It creates a copy of itself in the temp directory, right? And then it downloads Dire from some other website. Dire has this crazy word salad name, like 20 characters long, random letters. And it runs hooked to the process of this thing until this thing quits, and then it just runs in the background. So what does Dire do? What's it look like? Well, it's doing a lot of interesting stuff. So unlike Zeus, which was just basically a botnet Trojan that stole a bunch of passwords and then did the what we call man-in-the-browser attacks against banking logins. Dire does all of that, but it does a whole lot more. It does a lot of profiling of the infected machine, and it sends all that profiling data back over SSL. So some of the profiling it's doing is it's trying to determine what its public IP address is. So most people are running either on their home network or in the office on a NAT, right? And these network address translation addresses don't help a bad guy when he wants to connect back into your network. They need to know what is the public IP of that machine. So they're using a protocol that's pretty much been used by companies that do voice over IP. It's called STUN, tunneling over NAT. And it's a way of, it's basically a protocol specifically for voice over IP systems and voicemail systems so that they can get a public IP so that when when someone wants to call you on your voice over IP phone, that box that's being used to connect gets a connection from the phone company. And STUN is able to do a lot of interesting things. It's not only able to tell you the IP address, but it's able to characterize the NAT by symmetric NAT, asymmetric NAT, and basically give them a lot of information about how the network is configured where the infected machine is located. And it transmits that information, again, over HTTPS in part of the URL string that it's sending as a request back. So it sends basically a really long query string back to the server, and the server responds with /1/. Okay, I understand. Message received. So all of the data exfiltration is happening in the URL itself, and you can see that there's things like the name of the machine. The name of the machine in this case was called Victim. W512600. That's Windows NT 5.1 or Windows XP version 2600 or SP1. And then there's a unique identifier for that machine, and then it says NAT, symmetric space NAT. So interesting stuff. Dire is, like I said, using SSL. They, for a long time, were using a fake Google SSL cert. And I know everybody here is from California, and you all know that Google is not located in Miami, Florida. But that's the cert that they were using. They were using that cert for probably a good 4 weeks. And now they've switched over to a cert that says they're an Australian company. But basically, that's an example of what the SSL cert looks like from that traffic. Here's an idea of sort of, again, a breakdown of what all these things are. There's a version number for all of these things. The version number is the day of the month and the date. So today is September 24th, and today would be 2409. For some reason, all the ones that they're distributing in the US have the initials UK in them, presumably because it's British English. Again, there's the version number of the machine, unique identifier for it, there's a command that happens, and that's it. That's how it's transmitting its information. You can see all of these were taken out of SSL, so it does this transfer of what it calls a public key. It's doing some encryption of other data that go between the infected machine and the server. That has to involve a key exchange where the infected machine sends a key back to the original server, and that happens in the very first connection. Then it's saying WinXP 32-bit, and there's the IP address. It's telling you other system, symmetric NAT, user, not support, and then it does these browser snapshot things and other profiling of the infected machine. Sorry. Make that go away. Here's what the content of the browser snapshot looks like. So this is the data that was inside of that session where it said browse snapshot. It's showing you, so it's running Service Pack 3. It's got my time zone, Mountain Daylight Time, Mountain Standard Time. It shows the names and the versions of the browsers that are installed on the machine. And then it also sends all of the cookie data for all those cookies that are saved in the browser cache. So it's basically stealing all your cookies. This is the content of the next thing, which is called general info. And it wants to know what all your programs are and all the services that are installed and running on your machine are. And so it gives you it basically sends this big long file listing all of the installed programs, all the running services, all the drivers that are installed. They're doing a lot of profiling of these infected machines. Why are they doing it? We don't really know. We just know that this data is walking out of the network from every infected machine that's infected with this Trojan, and there must be tens of thousands of them. All right. So there's other SSL traffic that's malicious. There's abuse of cloud services. This one shows one of these spam messages with a link to download your invoice. It comes from Cubby.com. Cubby's like Dropbox. In addition to Cubby, the other cloud services that we've basically seen infected and used in this way, Amazon Cloud, Microsoft Cloud, Google Docs, Dropbox, Box.com, Cubby.com, Copy.com. There's a lot of them. All file storage services are basically potentially ripe for abuse this way. And once again, because these services all use HTTPS by default, they're basically counting on the protection of that HTTPS tunnel to hide the fact that a typical network device that's not doing this decryption would not see this file coming over the wire and wouldn't know to stop it. And it was just a zip file. It was another one of these Upatri or Huluos-like Trojans. Here's some examples of what happened when Upatri was doing its download.
Question.
Oh yeah.
Sorry, just a very basic question.
Yeah.
And so when you see these zip URLs, is this something that requires user interaction? In other words, they have to click on it and open it?
Yes.
And, okay. So,
Yeah, it requires the user to be like plausibly sort of a party to this infection. Yes. So user education is a big part of what my job is. I'm hoping that user education is a big part of your jobs as well, but even though we do as much as we can to tell people, don't just click random links to download zip files, it's hard.
Even in the computer, without admin privilege, they still can install everything they want?
That's a good question. In some cases, yes. Most of the stuff that I'm doing testing with, I'm testing using Windows XP, but we have noticed that there are certain Trojans that can run under Windows 7. They don't somehow, I don't know how they're doing it, but they don't invoke user access controls, and yet they're able to do their thing. Sometimes they do, but how many users do you know who, when a little dialog pops up that says, do you want to run this thing, and it just says yes, no, and they're in the middle of doing work and they don't know what's going on, they're just going to click yes to make it go away.
But some files like ESE, that means admin right can run ESE.
Oh, they don't need admin rights. They just need user rights for the logged in user.
Right.
In the case of
Like
Windows 7.
PDF, like a Word document Excel, they can open anytime, this time.
Yes, and so we do see, in addition to the zip files that are being delivered by spam, RTF documents, .doc files, .pdf files being delivered on a regular basis that have been weaponized, and they either contain JavaScript inside or Visual Basic script inside that goes and downloads another payload, or they contain the payload itself, and by opening that doc file, it starts the process of loading that file out of the binary format that they've stored it in inside. It sometimes takes a few seconds for it to run and crank through all the numbers to turn it into an exe and write it to the file system, but they're basically abusing all file formats. So there isn't really a file format that you can trust other than plain text, even doc files. And we're starting to see a lot more of those. When these security people talk about these advanced persistent threat type attacks that are coming out of China, almost all of them are Word docs or RTF files. We're seeing a lot of the Russians using weaponized PDFs that contain what's called active script in the PDF, and the active script goes and pulls a file from the server, very similar to the way Upatri would do it, only it's in a PDF, so it relies on a vulnerability in Adobe Reader to work.
Yeah, can I ask one other question?
Yes.
And so if you're up to date with your Java, Silverlight, and Adobe, are there still, there's still 0 days, right?
There are. Well, there's also the vulnerabilities in the browsers themselves, and there are 0 days against other apps that we don't know about. And the fact is that a bunch of the weaponized PDFs that I've seen, even though they indicate from their source code that they are only vulnerable, they only attack these vulnerable versions that are pre the latest version of Adobe Reader. Several of them only run in the latest version of Adobe Reader, and they throw an error in the earlier versions. And so I've reported this to Adobe, and they were kind of shrugging and incredulous. But yeah, we'll see if they issue another patch to deal with that. So, any other questions? Yeah, go ahead.
How about with Apple devices? Are you also testing Apple devices?
We do. We run Apple devices in the network. We see that they're sometimes targeted for malvertising, but again, the stuff that targets Apple devices is very similar to the stuff that's targeting Android devices, in the sense that it just prompts you to download something that you wouldn't otherwise want or need, but it does it in a way that makes it look like you're getting some kind of an alert from Safari or from from iOS. That there's some problem with the operating system. Again, it all relies on the user being kind of credulous and looking at this and not being able to make the distinction between a legitimate warning message from the operating system and this like fake script that's running off a browser page. And sometimes it's very obvious because you can see that it's like a small browser window with a title bar and everything, and other times it's a JavaScript that throws up a little box that's sort of indistinguishable from an operating system message. So it kind of depends.
Okay, thank you.
Yeah. Yes?
You talked about the items that get in and then they do their stuff, become invisible, and then they're running in the background and can't be detected. So what's the remediation strategy for that? Is it just re-imaging systems periodically, or what? How do you get at those?
So there's very few, almost no malware that doesn't involve the network in some way. So once you understand what you're looking for in terms of the beaconing, you don't need to periodically re-image all your systems, but probably the quickest remediation solution for most people is going to be re-imaging those infected systems. They are cleanable in most cases.
But if you, what if, is there stuff, eventually this stuff all gets into the definition files and can be caught, or is there stuff that truly, like you showed the example of the one that renamed itself, and then it's running there. So eventually, will the antivirus stuff catch that?
The AV stuff will eventually catch up to it.
Okay.
So we're not an AV company, so what we do is we get these files, and then I submit them into a service that's called VirusTotal. And it's a free service. I don't know if you know what it is, but basically they have every AV engine running, and you submit files up to it, and it scans them against all those engines, give you back a nice report that shows what all of the different engines would have said it was if they'd seen it today for the first time. And often they've seen them before, but many of them they don't. When you submit anything to VirusTotal, all those companies that are participating in VirusTotal get copies of that, and that includes us, because we acquired a company called Norman Shark last year. They're the company that made the malware analysis appliance that we use now, and they get a feed from VirusTotal of these files. It's just the problem is that the volume of those files is so big, and I know this from having worked in the AV industry before I worked at Solera, that there's usually a 15 to 45 day lag from the time that they've received the file till the time that they're able to process through it, know that it's bad, and add that like signature of that one thing to their definitions. So there is a lag time, and it can be pretty long.
if you're scanning the system, eventually when the 45 days goes by, it should eventually get caught.
Yeah,
And
but
you
45
really-
days of a piece of malware running on a box
Right,
is
right.
like that's a disaster. That is really like an epic failure of security. You know, if you're not dealing with these things within minutes of them getting on the infected machine, you're into very serious problems, even just after a few minutes. After days, it's really a nightmare, and then after weeks, most of these infected machines don't get discovered for weeks, typically. So it's not, I mean, you're describing a pretty common scenario, but it's still a disaster.
Right.
The fact that weeks happen, that the machine is running, that people are logging into various private things all this time is really bad. I'm getting kind of close to the end of my time, so I want to keep going here. So this is really, these are the 5 questions that we seek to answer. We're trying to get to the root cause of these attacks. We want to be able to give you very quickly who is infected, what were they infected with, what left the building, you know, is anybody else affected by this? And maybe you've remediated one machine, but do you know if 5 others have been infected? And we want to be able to give you this information as rapidly as possible, because these are the questions that your boss is going to be standing over your shoulder all night if he has to or she has to, wanting to know the answers to these things, because you're going to have to make some kind of public statement about it. And that's our goal. We want to be able to give you all of that information, and in most cases we can. The reality is that these things are going to happen. Okay? It's not a question of if, it's just when, and they're probably already happening right now on your networks, and I know you probably don't want to hear me say that. And so the idea here is, instead of trying to build up your walls bigger and bigger and bigger, be expecting that these things are going to happen, and be ready to just get that stuff. The tools that I showed you today, they're kind of like a security camera in a bank. 90% of the time, or 99.9% of the time, those cameras are just going to be recording people doing their normal transactions, and it's not going to matter. But that one time when a bank robber walks in, it lets the police identify them, it lets them know, you know, their height, their you know, basically their profile, and be able to publish that out to the world. That's the kind of information that we would want to be able to give to you to protect the users on your networks, and by extension, you know, citizens of the state of California who all depend on you. So that's pretty much my presentation. It's usually around this time that I go through demos, but since I only have 45 minutes and I'm at 43, I'll just see if there's any more questions. And you can always come by. So I work for Blue Coat, where our booth is just over here in the floor. Please come by. I can show you a demo afterwards if you like. I have business cards if you want to stay in touch with me. And for those of you who are in law enforcement, I just wanted you to know that we help law enforcement with investigations. Our WebPulse database of reputations on IP addresses and domain names goes back 10 years. So we know all the bad neighborhoods in the web. If you ever have any questions, or you're working on a case where you're doing an investigation and you need background information, please feel free to reach out to us and contact us. We're happy to help, and we want to stop the bad guys as much as you do. It makes my day a little bit brighter when I know that I've affected their business model. So thank you all very much for attending. I appreciate your time.